We're going to use a technique of integration called the method of partial fraction to integrate 2x squared plus 1 divided by x minus 1 times x minus 2 times x minus 3. First note that this function we are integrating is called a rational function. It is just a polynomial divided by another polynomial. Before we can proceed with the method of partial fraction, we have to make sure that the degree of the numerator is strictly less than the degree of the denominator. So in our case, the degree of the numerator is 2, and the degree of the denominator, we have x minus 1 times x minus 2 times x minus 3. The 3x's, when multiplied, will yield x cubed, so degree of the denominator is 3. So in fact, it is true degree of the denominator is greater than degree of the numerator. If that's not the case, if they are equal or degree of the numerator is bigger than the degree of the denominator, we first have to perform long division and then use the method of partial fraction. The next thing we look at is the denominator. You see that it is a product of 3 distinct linear terms. So 3 distinct linear terms. A linear term is just a polynomial of degree 1. These are all different. Therefore, the partial fraction decomposition looks like this. 2x squared plus 1 divided by x minus 1 times x minus 2 times x minus 3 will be expressed as a over the first linear term, x minus 1, b over the second linear term, plus c over the third linear term. Once we find a, b, and c, the integral on the left and the integral on the right are the same. The integral on the right is much easier than the integral on the left, and we'll be able to solve this problem. So problem comes down to finding a, b, and c. To do that, we're going to multiply both sides by x minus 1, x minus 2, and x minus 3. So x minus 1, x minus 2, x minus 3 times 2x squared plus 1 divided by x minus 1, x minus 2, x minus 3. As you can see, these cancel. And on the right it looks like this. A divided by x minus 1 times x minus 1, x minus 2, x minus 3, so we can cancel x minus 1 here, plus b divided by x minus 2, x minus 1, x minus 2, x minus 3, so here x minus 2 cancel, and then c divided by x minus 3, x minus 1, x minus 2, x minus 3, so here x minus 3's cancel. Let's see what's left. On the left we have 2x squared plus 1, and on the right we have a times x minus 2, x minus 3, plus b times x minus 1 times x minus 3, plus c times x minus 1 times x minus 2. Now to find a, b, and c, we simply are going to select values of x that will make some parts on the right 0. Those values are x equal to 1, that's going to make b term and c term 0, x equal to 2, and x equal to 3. And this will enable us to find a, b, and c. So let's go ahead and compute those in each case. When x equal to 1, the left-hand side looks like this. 2 times 1 plus 1 is 3. On the right, the b term and the c term will cancel, will be 0 because they have x minus 1, but the a term will not be. We have a times 1 minus 2, which is minus 1, times 1 minus 3, which is minus 2. So that is 3 equal to 2a, and we found a. A has to be 3 divided by 2. Plugging in 2, we have 8 plus 1, which is 9 on the left. The a term and the c term will cancel. Only the b term will not. So b times 2 minus 1, which is 1, times 2 minus 3, which is minus 1. Therefore, 9 is equal to minus b, or b is negative 9. Plugging in 3, we get 9 times 2, 18, plus 1, 19 on the left. The a term and the b term cancel on the right, and we have c times 3 minus 1, which is 2, 3 minus 2, which is 1. So 19 is equal to 2c, and c is equal to 19 divided by 2. That pretty much solves the problem, because we have our integral, which was 2x squared plus 1 divided by x minus 1 times x minus 2 times x minus 3, is now integral of a divided by x minus 1. So a is 3/2. We can pull it here in front. So it's 1 divided by x minus 1 plus b. b is negative, so it's minus 9 times the integral of 1 divided by x minus 2 plus c, which is 19/2 times the integral of 1 divided by x minus 3. And all three of these integrals are just natural logs of the absolute value of the respective denominators. So this is equal to 3/2 natural log of absolute value x minus 1 minus 9 natural log of absolute value of x minus 2 plus 19/2 natural log of absolute value of x minus 3. Now we can add a c here, and that's the answer, but some instructors prefer to leave the answer as a single log. So the way to do that is to look at the coefficients in front of the natural logs. We have 3/2, 9, and 19/2, so the common denominator there is 2. So we're going to take 1/2 times 2, that is just a form of 1, and multiply it by 3/2 natural log absolute value x minus 1 minus 9 natural log absolute value x minus 2 plus 19/2 natural log of absolute value of x minus 3. C is unaffected because we can just relabel it, so leave the c out on the outside the brackets. Now send the 2 in. We have 1/2 times 3 times natural log of absolute value x minus 1 minus 18 natural log absolute value x minus 2 plus 19 times natural log of absolute value of x minus 3 plus c. And now we can combine what's in the brackets to make it look nicer. It's 1/2 times the following natural log. Absolute value x minus 1 cubed times x minus 3 to the 19th divided by, because of the minus, x minus 2 to the 18th plus c. And one more thing, because the x minus 2 term is raised to the 18th power, it will always be positive whatever x is. We can't have x equal to 2, but anything else, because of the 18th power, will make it positive. So technically we do not need absolute value, and you can rewrite your answer like this: 1/2 natural log of, in the numerator, absolute value x minus 1 cubed times x minus 3 to the 19th, and then in the denominator x minus 2 to the 18th power plus c. And that's the answer. So that's how we use method of partial fraction when the denominator